Welcome to the Aviators Preparatory Training Solutions computer-based training. The content on this CBT is meant for the Boeing 737NG initial preparatory training, as designed by the vendor. Company Standard Operating Procedures, Flight Crew Operating Manual, FCOM and Flight Crew Training Manuals, FCTM supersede this material. This video shows the initial pre-flight setup of the flight management computer, referred to as the FMC. The setup shown in this video describes the pre-flight setup of the FMC during a turnaround. A turnaround is a term used to refer to the process or the act in which a ship, aircraft, etc., unloads passengers and freight at the end of a trip and reloads for the next trip. The setup shown here can also be used during the FMC pre-flight for the first flight of the day. During a turnaround, to set up the FMC for the next flight, both IRS switches are momentarily flipped from the nav to the aligned position. This will cause the FMC to request information required by the IRS to align with the aircraft position. Click the Init Ref button on the FMC pad to switch to the Pose Init page, then click on L1 Select key to insert the airport identifier of the airport you are currently located at, then click on the Next Page button to get the GPS position of the aircraft from the Pose Ref page. This would be the longitudinal and latitudinal position. Select GPSL or GPSR, either will suffice. Then click the Previous Page button to revert to page 1 of the Pose Init page. Here, enter the selected information which you should see at the bottom of the FMC screen by selecting the R4 Select key. Once this is done, flip the IRS switches, which can be located on the aft overhead panel to nav, verify that both aligned lights extinguish. This whole process is called the fast alignment. Now move to the route page by clicking on the RTE button or the R6 key as you can see on the screen. Enter the origin airport using the entry pad or keypad by selecting the L1 key under origin, then enter the destination airport by selecting R1 under dest. Now, under the FLT No, which stands for flight number, enter the flight number of the flight, in our case, it is ARA 402, and enter the runway for departure from the originating airport under runway, in this case it is runway 22. Click on the Next Page button to move to the second part of the route page. Here, you should enter your flight routing as given in the operational flight plan. In this page, you will notice that to the right of the screen you have to, and to the left of the screen, via. Enter only fixes and waypoints under the to section to the right using the keypad to type, and select into the dashes using the R select keys. Enter only airways under the via section to the left using L select keys. When you are done, select the Activate button using the R6 Select key, then click the Exec button to execute. Verify the light that comes on activating above the Exec button extinguishes. Usually, you should verify any and every entry made with the other flight crew before executing. Click on the R6 Select key to move to the Perf Init page. Here you enter your airline's default zero fuel weight under ZFW, in this case, 50 for the 700s and 55 for the 800s. This will be later adjusted to meet the load sheet requirements. Next, under Reserve, enter the reserve fuel as given on the Operational Flight Plan OFP. This would be a sum of the fuel required to divert to a selected alternate airport, final reserve fuel and contingency fuel. In our case, we entered the planned fuel for departing out of our destination airport, 5.4, as we would be tankering or carrying sufficient fuel to get from the destination airport to the next. Now, under cost index, which is the ratio of the time-related cost of an airplane operation and the cost of fuel, enter your airline's default cost index. In our case, this is 35. To the top right side of the Preflight page, you have the trip or CRZ alt page. Enter the planned cruise flight level as stated on the OFP. In this case, we enter 200 representing flight level 200. Next, we enter the transition altitude of the origin airport under Trans Alt. In this case, the transition altitude for our origin station, Abuja, is 5,000. This entry could be used as the first trigger to bring out departure and approach plates for the flight. The cruise wind, which is depicted on the Preflight page by CRZ wind, is the next entry, and the information for this is gotten from the OFP under the route brief. The cruise wind is gotten from the top of climb section, which is identified by the abbreviation TOC. Now, look under the column, wind. In this case, our cruise wind is 09023 knots. Beneath the wind is the ISA deviation. Enter this information under ISA dev, in this case it is P16. Only 16 is entered. Always remember that you should always verify entries made on the FMC before executing. The exec light comes on when a change has been made, and the change is stored by clicking the execute button. This in turn extinguishes the exec light. Click on the R6 select key to move to the N1 limit page. This page can also be accessed by clicking on the N1 limit button. The only information to be entered at this pre-flight stage of the FMC is the reported temperature at the aerodrome of departure. This should serve as a trigger to get the departure weather from the aerodrome of departure and get the arrival weather for the destination aerodrome. This information should be written down in the spaces assigned to them on the OFP. Enter the temperature using a /, then the temperature into the L1 select key. In this case, the reported temperature is 28 degrees. The remaining requirements for this page will be completed when the load sheet is received and values received computed against the associated aircraft performance analysis table. More light will be shed on this in a different lesson. Once again, click on the R6 key to move to the takeoff ref page. Here as well, the only information to be entered at this initial pre-flight stage is the flaps to be used for takeoff. This is entered into L1. In this case, we intend to use flaps 5 for this takeoff. Then, click on the next page button. Enter the value 1000 into L5. This is under reduction THRC LB. This would be the thrust reduction altitude above ground level. Now, click the CLB button to view the climb page. This page holds the aircraft's phase of climb information. Here verify the information matches planned values. Mainly, verify CRZ alt as matching planned cruise altitude and the SPD rest having the required speed against the altitude to which the initial climb speed restriction will be applied. In this case, we restrict climb speed to 250 knots below flight level 100 as per company SOP. Click the CRZ button to access the Econ Cruise page. Here, you verify the cruise altitude, optimum and maximum altitude possible, as well as the expected arrival fuel at the destination aerodrome. In this case, the value is currently 2.2 because we haven't refueled yet. We should get at least 5.4, which is the planned fuel, to depart from the destination aerodrome. Next, click on the DES button to access the descent page. Here, you should verify the values. For instance, the SPD rest in this case has only dash lines and should be filled with values to restrict descent below a specific altitude if required. In this case, we enter a restriction value speed of 240 knots below flight level 100. This is as per company SOP. Here we can see that we have 240 /10,000. This is because the default transition level on the FMC is set to flight level 180 but can be modified. This should serve as a cue to look up the forecast page. Now, execute this entry. Then, we click on the line select key L6 to access the forecast page. On the forecast page, we verify the transition level of the destination aerodrome. In this case, it is flight level 50 as verified from the arrival charts of the destination aerodrome. Then, we enter the descent wind information against flight levels given on the OFP. This information can be found in this case either from the top of descent information of the legs or routing section, or gotten from the en route descent information. It is entered with the flight levels to the left and the wind direction forward / the speed to the right is seen. Now, execute the modification. Be reminded that when you are on the forecast page and require the transition level, this is the second trigger to remind you to bring out the departure, approach and aerodrome charts. Click on the Prog button to access the progress page. The first page you view is the first of 4 pages of the progress page. Here, you cross-check the summary of the routing, verify the estimated landing fuel at destination, and verify the total distance matches or is approximate to that on the OFP. This could serve as a means to catch errors in routing. For instance, if the total distance from Abuja to Port Harcourt on the OFP reads 313 miles, the distance on the progress page should read at least plus or minus 10 of that distance. In this case, the total distance on the OFP reads 193 miles, and that of the progress page, 200 miles. This is an acceptable margin. Click on the Legs button to access the Legs page. Here, you verify each point matches that on the OFP under the route brief, then, if you are not departing on an SID, you can double-select the L1 key then enter the on-course track for the on-course waypoint. In this case it's the second waypoint on the legs page with a track of 273 degrees. Enter this into the R6 line select area and execute the modification. Now, set this same value of 273 on the mode control panel's course window using the course selector. This is done also to serve as a redundancy in the event of a loss of both FMCs for en route navigation when reverting to basic navigation. Also, though not shown here, click on the R6 line select to access the RTE data section of the legs page. Here you enter the corresponding winds of each waypoint that corresponds to the OFP route brief waypoint winds. These are entered for waypoints that have blank boxes. These helps for better flight computation by the FMC. Click on the Fix button to access the Fix page. There are 2 sections to this page accessed via the Next or Previous Page buttons. Here, you should enter a waypoint. In this case I prefer to enter the VOR of the destination aerodrome on the first section, and then enter a distance from the VOR at 25 miles. This is as per company SOP. The 25 miles is entered by first placing a forward / then 25. If you were to enter a radial alone, or a radial, and a distance together then you would first enter the radial alone as say 250 or 250 forward / 25 miles respectively. Go to the next page and enter the same as done on the first page, only this time, the waypoint used could be the VOR of the origin aerodrome. Again this is a personal preference as guided by the SOP. The entire information entered into the Fix page is mainly for situational awareness. Once the distance is entered against the VOR, it creates a ring at the distance entered from the VOR, and if a radial is entered, it draws a line to depict the radial from that VOR. Now that the initial preflight of the FMC is completed, you can set the minimum flap retraction altitude, MFRA, using the Baro selector on the FS panel. The MFRA in this case is 1,000 feet above aerodrome level, and in this case this would be 2,200 feet set. Check that you have set your flight number on the control column or yoke as it relates to the flight and verified from the OFP. Now, in this case shown here, if you haven't taken down the departure aerodrome weather, this is the best time to tune to the ATIS frequency if there's an available ATIS or request it from ATC. Then, cross-check and enter the values of all altimeters when the QNH has been set, ensuring that they are within limits. You can also use this opportunity to get the arrival aerodrome's weather if you haven't gotten it as well. In this lesson, we have reviewed a pre-flight setup for the FMC during a turnaround on the Boeing 737NG.